Hi, I'm Melissa Fassbender with Product Design Development. I'm here with John Austin of Microchip at Sensors Expo 2015. We're here talking about the PAC1921. Now, could you tell me some unique features and benefits?
Yeah, so the PAC1921, I mean, the thing that makes it unique is the fact that it has a two-wire interface, I2C, and it integrates an analog output that is configurable to get power, voltage, and current from the power bus.
What are some design challenges that this product solves?
So one of the design challenges that it solves is that in many systems, actually in a manufacturing environment, data latency from the communication can be an issue. So by allowing being able to have the analog output configurable, customers can decrease that data latency or minimize it to almost zero and increase their manufacturability of their product.
What are some example applications?
There's a lot of applications for this device. I mean, if you think about the industry today, you know, everything's green. They care about power consumption. There's, you know, battery-powered applications and battery-powered devices are everywhere that care about power consumption. For quality and reliability reasons, people want to know what subsystem in a system's doing what and consuming power to monitor different things. So this device adds that flexibility to all those systems.
Yeah, that's great. And how about a quick demo for us?
Okay. So this is the PAC1921 demo board. The first thing that you should note is all the ICs on the demo are actually from Microchip and manufactured by Microchip. So this would be the PAC1921. Down here we have the MCP2221, which does the USB to I2C to communicate between the PC and the PAC1921. And then we have a couple of MOSFETs that generate a current source, a programmable current source that we can use to drive a current across the shunt. So just a really quick overview of the demo. The quickest way to get it running is actually just to hit function F2, and that will open up basically this calculation tab. And it puts it in a free running mode so that it's always converting data and displaying it in this tab. So this gives you basically the bus voltage, the current and the power, and it also shows you the information in the accumulation registers. So down in the bottom left corner, you can see where you can adjust the voltage across the shunt. So you can do that either via this knob, I can turn it, or I can just type in a value. So I'm just going to put in 40 millivolts. And then up here are the tabs that actually show the data logs. So if I click on, say, the V bus, you can see that the bus voltage is at about right under 5¼ volts. And the sense voltage, you can see where I made the change, sitting right at 40 millivolts. And again, so if I change, I can tune this to different values, and the current sources change the current to generate that value across the sense resistor. And then here this shows the power calculations. So the other features that we discussed during the presentation would be the ability to change the resolution for the current and the voltage. So you can select those up here. You can select different current gains and voltage gains. So again, current gain up to 128 and voltage gain up to 32. And then this would be to enable or disable the internal digital filters. And that's pretty much it at a high level. So one of the most unique things about the PAC1921 demo, and what I think is one of the most useful things, is when they designed it, they made it very modular. So I can connect here to an external I2C, my system to the I2C bus, bypassing the USB to I2C converter that's communicating from the PC and communicate directly to the PAC1921. That way I can actually implement it in my system to evaluate it. And I can connect an external load through these connectors so that I can emulate either my system load or even connect my actual system load to the PAC1921. And then I can bias everything up through this connector so that they all are on the same ground plane, and it's at the same ground as the system I want to evaluate it in.
Thanks for the great demo, John. This has been the PAC1921 with John Austin of Microchip.